when we use the animation and tracing facility, which is provided to us in Omnet through the TK environment, we still feel that at times the interaction between modules and objects is so complex that we cannot track of it visually. So we need another tool to provide us more insight into the relationship and the moving behavior between modules and objects. Here comes the role of sequence charts. In this module, we are going to understand what are event log tables, how are these related to the sequence charts, and what exactly are the sequence charts. Event log tables are actually files which provide tabulated logs of the messages which are sent during the simulation, the events which cause these messages to be sent. These messages could be sent between modules or from a module to itself, which is here called the self message. Since the event log table is likely to explode because when a simulation is taking place, and if it is a large simulation, it will generate a lot of events. So logging them all might not be advisable. In that case, Omnet++ provides the user with the control to determine how much amount of data is to be logged. So the user is given the control to start and stop the event recording and which modules are to be included in the log and which modules are to be left out. The event log file creation is the starting activity that eventually becomes useful when we relate it to the sequence charts. So the event log files are created either through the command prompt or through the graphical interface. In command prompt, all you have to do is type record even log equal to true. When we do that, the events start getting logged and the output is stored in log or elog file in the format which is shown to you in the results directory. Using the graphical interface, it becomes very simple. We simply check the record events option in the initialization file configuration window. Once we have the event log, now it is time that we start seeing them in a useful way. So sequence charts actually allow us to display the contents of the event log files graphically in a highly meaningful way. Using sequence charts, we can focus on to the real stuff and find out the causes which result into the transmission of messages, occurrence of events, and their consequences. Sequence charts actually help the users of Omnet++ to understand complex simulation models visually. And it also helps to verify that the implementation of the simulation is actually complying to the desired real-world scenario. Before we delve deeper into sequence charts, it is important to understand the legend first. The first important object that you see here is the simple module axis. Now, the mention of axis here means we'll have two axes, the x-axis and the y-axis. If we have a simple module that we want to capture the behavior of visually, we use a single line for simple module. For compound module, we use double line. If we want to annotate a module with some kind of vector data, for example, the names of different steps or sequence of steps in the life of a module, we can do that by attaching the vector data to the particular module and its axis. This shows the module full path as axis label. These circles, the hollow circle, the green circle, and the red circle show the initialization, the self-processing, and the message processing if it arrives at a certain module. The event number, the self message shown through an arrow, the message which is sent in case a message gets reused. For example, in retransmission, the packet in the send buffer is simply retransmitted and no new packet is created. The method that is invoked in a certain module at an instance of time. If on the sequence chart, the number of objects that are being shown on different axes are many, and if one module is talking to another module and they're quite far away in the sequence chart, then using a discontinuous line, a relationship can be shown between two modules sharing messages. The message name is shown in blue. The method that is invoked is shown in brown. We'll come to this concept of zero simulation time region later, but for the sake of brevity here, I'll just say that when two events occur at the same time, they both are given the color gray. And the literal time on the time axis is shown using the dashed gray hairline.